All right, welcome back. We're going to look at problems 26 to 28. We're asked to draw a picture, label, and solve. Number 26 says the sides of a triangle have lengths x, x plus 17, and 25. If the length of the longest side is 25, what value of x makes the triangle a right triangle? So let's go ahead and draw my right triangle real quickly. So here's my right triangle. And the longest side is 25, and of course the hypotenuse is always the longest side of a right triangle. So this is my hypotenuse, and it's 25. And then we have our legs, which are x and x plus 17. So x plus 17. And we're going to go ahead and apply the Pythagorean theorem. So we know that C is always the hypotenuse. So I can go ahead and replace C with 25. So 25 squared, and then A and B. So we have x squared plus x plus 17, the quantity squared. So let's go ahead and expand this. So this is going to be x squared plus x plus 17 times x plus 17 equals 625. So I have two binomials here, and when we're multiplying two binomials, we're going to FOIL. So it's going to be first, so let me write this, x squared plus my first, which is x times x, that's x squared, outer, so that's x times 17, which is 17x, inner, which again is 17x. And then lastly, we have the last. So that's 17 times 17, which is 289, positive 289, which is equal to 625. And then I'm going to go ahead and combine the like terms. So we have 2x squared plus 34x, and then plus 289 equals 625. And we have something in the form ax squared plus bx plus c. If you can look here, we have a quadratic, but on the right-hand side of the equal sign, we have a number. This needs to be 0, right? So what we need to do is subtract both sides by 625. So we get 2x squared plus 34x minus 289. Sorry, I should say, so we have positive 289 minus 625, which is minus 336, right? So minus 336 equals 0. Okay, I can see that we can factor out a GCF of 2. So let me write a note here. We're going to factor GCF, which is 2. So 2 is going to go outside. And then we have x squared plus 17x minus 168. And don't forget, we are setting that equal to 0. This is what I'm focusing on right now. So we have a quadratic, and a is equal to 1. So I can go ahead and use the x method. So let's draw the x, and c is going to go up top, and b is going to go to the bottom here. So now I need to think of two numbers that multiply together that'll give me negative 168. And these two numbers, those numbers that you picked originally, gotta add up to 17. So let's try 24 and negative 7. 24 times negative 7 is negative 168. And 24 plus negative 7, or 24 minus 7, is 17. So I can go ahead and write this out. 2 times the quantity of x plus 24 times x minus 7 equals 0. So then what I'm going to do is I'm going to take this, and set it equal to 0. So x plus 24 equals 0, which if I subtract 24 on both sides to get x, I get x equals negative 24. And I can do the same thing for this factor here, which is x minus 7 equals 0. And you're going to add both sides by 7 here, so you get x equals 7. And what is the best x value? Well, since we're dealing with a right triangle, there's no such thing as negative length, so your best answer is x equals 7, not x equals negative 24. All right, so that's number 26. All right, so we have number 27 here. The bottom of a ladder must be placed 3 feet from a wall. The ladder is 10 feet long. How far above the ground does the ladder touch the wall? Round your answer to the nearest tenth. All right, so we have a wall. I'm going to go ahead and draw my wall. Doesn't have to be a perfect sketch, but I just want to visualize what's going on, and I can label it, and then I can solve, right? So the ladder must be placed 3 feet from the wall, and the ladder is 10 feet long, right? So this is going to be my ladder, which is 10 feet long, and the ladder, again, don't forget, it is placed 3 feet from the wall, right? So this is going to be 3. How far above does the ladder touch the wall? Okay, so it's talking about, okay, this is from the bottom all the way to the top here. So this thing right here, okay? So I want to figure out the length of this side, which we don't know what it is. So we're going to go ahead and call this x. And let's just throw in a right angle there, because we're just going to assume that the bottom is flat, right? So this wall is perpendicular to the ground. And yeah, so we're going to go ahead and apply the Pythagorean theorem. This right here is going to be my c value. So 10 squared, and then a is going to be x, so x squared plus b is going to be 3, so 3 squared. And then what I'm going to do is just figure out what 3 squared is. So x to the second power plus 9 equals 100. So now I have x squared equals, what is that going to be, 91. And now I'm going to go ahead and take the square root on both sides, right? So x equals, what's the square root of 91? Let's see if I have my calculator out. Okay, so second, x squared, type in 91, hit enter, and I'm rounding to the nearest tenth here. So looking at that 3, it's going to dictate the 5, but since 3 is less than 5, well, the 5 isn't going to change, so x is equal to 9.5. All right, so number 28, a soccer field is a rectangle 100 meters wide and 130 meters long. The coach asks players to run from one corner to the other corner diagonally across. Find that distance specifically. Round your answer to the nearest meter or whole number. So I'm going to go ahead and draw my rectangle. Okay, there we go. That's my rectangle. And it is 100 meters wide. It doesn't really matter if you put 100 here or there. In fact, let's go ahead and put 100 here because this side is, smaller than that side, right? So this is 100, and then this is going to be 130. And we are telling the players, or the coach is telling the players, to run from one corner to another corner diagonally. So just like this. And since it's a rectangle, of course, all angles are right. Okay? So, you know what? I'm going to change this. Let's put the 100 over here. There you go. So now, what we're going to do is we're going to find the distance from this corner to this other corner, which we're going to go ahead and call X. So now, if we look carefully, we have a right triangle. So what are we going to do? We're going to go ahead and apply the Pythagorean theorem. And since we know that this side is the hypotenuse because it's across from the 90-degree angle, I can replace C with X. And then we have 100 squared plus 130 squared. And then let's go ahead and... Okay, well, this is beautiful. I don't really need to simplify radicals. I'm just being asked to round my answer to the nearest meter. So here, x squared is already by itself, right? So I can go ahead and take the square root on both sides. So I'm going to take the square root of x squared, and then I'm going to take the square root of the left-hand side of the equal sign. Now, do not think that the square root and the exponent of 2's will just go away. It doesn't work like that unless these numbers are being multiplied. So the safe thing to do in this case is to use a calculator. So what I'm doing is I'm going to input the square root of 100 squared plus 130 squared. And what you're going to get is... I'm looking at the answer key. I put 64 meters, but in this case, it's actually 164. So D, I think I have to change that on the answer key. Let's see. So X, or that distance, is equal to 164. All right? Okay. That's all I needed to say about that problem, and I am done.